Hi, Mrs. Bixler here with our second video of this unit, which is super exciting. Woohoo! So as we are putting more information into our proofs, I wanted to give you some more parallel postulates that you can use in your proofs to help you out and move through the journey. So before we go ahead and do that, I wanted to warm up a little bit. So I want you to pause the video and answer this question. All right, we're back. So we are trying to make A and B, those two lines, parallel to each other. So I know that I want this guy and this guy to be parallel. So let's see if this is going to be our transversal. And so in that situation, it winds up being our transversal. We're good. And so I know that X has to be 70 degrees because they're corresponding angles. They are in the exact same spot. And remember, you can check that and see if that's true if I take this little guy and I'm able to shift him over. Let me select him. And if I can shift him over and have him match up with 70. So X is going to be 70. And if X winds up being 70, then it's super easy to solve for Y. Ba, ba, da, ba. We get that Y equals 60 degrees. Woohoo! All right, on to the next one. Pause the video again and answer this question. All right, so in this situation, we are back and we are trying to prove that we're trying to make BC and AD. So be parallel to each other. In the situation on the left, here is our transversal. So angle A and angle B are going to be same side interior angles. So you know that they have to add up to 180 degrees. And if they are supplementary to each other, then we know that those two lines are parallel. So I know that X has to be 10. And then if we shift our gaze over to the right-hand side, we know that CD is going to be our transversal here. And so those are going to be same side interior angles as well. And so I know that those have to add up to 180. So Y has to be 45 degrees. All right, hopefully you feel good about that. So now let's move on to new stuff. So I want to tell you a little bit about perpendicular bisectors. So a perpendicular bisector does two things. The first thing that it does is it is perpendicular to the side that it is intersecting. So let's say that we're calling line BD a perpendicular bisector. That means that it is going to be perpendicular to line segment AC. And then the second piece is that it bisects line segment AC. So I know then that this is going to be the midpoint, right? And I know that AD is going to be congruent to DC. A perpendicular bisector is both perpendicular and a bisector. Amazing, earth shattering, I know. All right, and this is the fastest video ever because guess what? This next slide is our last one. So I just want to run through these little baby parallel postulates. Number 1 and number 3 are not as exciting, but number 2 and number 4 we will be using in our proofs. So for number one says if I have a line, there's always going to be a point off that line, right? We know that there are an infinite number of points off of a line. I'm going to be able to draw only one line that is parallel to that original line and through that point. Now let's go down and look at number 3, just because I told you it wasn't as exciting. So let's say that I've got two parallel lines and I have a transversal here, this little diagonal guy that's cutting through one of the parallel lines. If that transversal is cutting through one of the parallel lines, then I know, it has to cut through the other one. So, which makes sense, right? So if it's cutting through one, it's going to be cutting through the other one. All right, let's look on the right-hand side. These are the important ones. So the first one, if we look at number 2, and it kind of leads off of number 3, which I know the order is kind of off, but whatever, run with me here. So I know that I've got this line L, and line L is acting as my transversal through my parallel lines, line M and line M. Line L, that transversal, is perpendicular to line M. If it is perpendicular to line M, then watch. I know that this angle has a corresponding angle. It's going to be in the exact same position. So if this guy is perpendicular here, and if this guy's like 90 degrees, right? It's got to be 90 degrees. It's got to be perpendicular down here as well. So this is what we call para-perp. Because if I've got two lines that are and two parallel lines, and one of them is perpendicular to the transversal, I know the other one is also going to be perpendicular to the transversal. This is also just kind of a fancy way to use cap, right? Because they are corresponding angles. All right, last one. So this one's kind of cool. This is number 4. So this one makes sense because let's say that I know line L is parallel to line M. And I know that line M is parallel to line N. So using the transitive property, what do you think that would imply? Line L is parallel to line N. Ah. And so we call this paratrans. So if one line is parallel to another one, and that line is parallel to another one, then I know that this guy is parallel to this guy. And we call that paratrans. So paraperp and paratrans are two kind of newer postulates, and we're going to use those in our proofs. So go ahead, tackle the homework. You're going to crush it, and I'll see you soon. Thanks.